Welcome to another episode of the Unicorns podcast. I'm your host, Justin Kelly. Today's guest is building something that sits right at the centre of two of the biggest forces reshaping the global economy right now: artificial intelligence and energy. Because while everyone is talking about AI, very few people are talking about the infrastructure that actually powers it, and more importantly, where that infrastructure sits. Right now, Australia is producing enormous amounts of renewable energy that never gets used, while at the same time, businesses are paying a premium to access computing power that often sits offshore. Today's guest believes those two problems are connected and, more importantly, solvable. Andrew Sjoquist is the founder of WinDC, a company building what he calls portable, high-performance data centres that can be deployed directly at renewable energy sites, turning stranded power into real-world compute. It's a simple idea on the surface, but one that has the potential to reshape how AI infrastructure is built, where it lives, and who gets access to it. Andrew Sjoquist, welcome to the program.
Thanks for having me, Justin.
Where did the idea for WinDC first come from?
So the idea originated about 10 years ago. We were standing on a wind farm in northern New South Wales. This is the giant turbines that you see generating electricity. And we observed that there was a constraint with trying to actually get the power that was generated out onto the electricity grid, the big transmission wires that you see, and into the metropolitan cities. And as a result, the wind farm couldn't generate all the power that it was designed to generate. And so we asked the asset owner and had a discussion with them about whether or not it would be interesting for them to have some form of large electricity consumer at the site. And given my experience in data centers over the previous 20 years, it instantly came to mind, and we thought, okay, well, maybe we can get a data center, rather than operating the city, to be picked up and put in the regions where the electricity is actually being generated, and the concept was formed.
And for those that are not familiar with what a data center actually is, I mean, we've all heard of the term. Describe to us simply what a data center is.
Sure. In its simplest form, it's a giant hotel for computers.
Okay.
So basically, in their current deployments, they are big industrial warehouses with lots and lots of computers racked up in rows and rows. That requires obviously a lot of electricity to be fed into the building. It requires a lot of cooling to deal with the heat that's generated out of those computers. But it's basically what underpins the internet and now AI in our everyday lives. So there have been background infrastructures. You've probably driven past them almost every day and not noticed them. Now, pretty much everything you do, whether it's booking a flight or doing a Google search or asking AI a question, getting it to do a task, all relies upon a data center to be available and operational.
So how do you go from a concept, even the early start of an idea, into where you are now? The company's launched WinDC, you've got commercial partnerships, a financial runway, you've got interest from investors, people looking at you. How did that actually happen?
Yeah, what didn't happen was it wasn't overnight. We didn't just wake up yesterday and think, oh, this would be a good idea. It's taken that time over 10 years to craft the thinking. And the thinking sort of starts with the initial idea, and then it's about how to actually write it down and then keep iterating on it. So having discussions with people, with other experts, with other industry people, but also with people who maybe don't know the industry, trying to explain what is quite a complex topic to people who may be hearing it for the first time. And that often also exposes new things that need to be addressed in the thinking.
Yeah.
And as a result, we kind of arrive at a somewhat polished idea, which continues to change every day, mind you. Probably will do for the infinite future. But it starts to arrive at a concept that is explainable, executable, and then it's about finding, right, where do we find the team and assemble the team to make this vision into a reality.
So did this start off for you as a side hustle, as just this is an interesting idea I'm working on off to the side, and it's obviously morphed into something much more?
That's right. Yeah, it was a side hustle. So about 25 years ago, I started a company called ASC Tech. That company is an IT services company. So we do a lot of technology services for a whole range of different industries. But one of our specialties that we've developed over the last 15 years is in critical infrastructure assets. And so that basically entails us providing connectivity services and cybersecurity services and data management services to a whole range of critical infrastructure assets. And that includes ports, it includes generation facilities like your wind farms, your solar farms, your batteries. And it was through that business that the opportunity kind of became obvious through our exposure to that industry. And we're able to get the really early glimpses through great discussions with our customers that this was a problem that was beginning to grow. And that potentially through our exposure in data centers, having operated in that space, that maybe the two things could come together and a problem could be solved.
And so was there a moment for you, Andrew, when you realised something fundamentally wasn't working in how Australia builds and uses AI infrastructure?
I think it was a little bit hiding in plain sight. So AI really has only been at the forefront of people's minds probably for about 3 years. ChatGPT was probably the most famous with OpenAI, but I mean, really the concept's been around for decades. And so as we've started to see the growth of that sort of mainstream AI adoption and the technology industry that goes around that, namely NVIDIA, but there's also now other sort of chip manufacturers as well, but NVIDIA's probably been the fastest sort of growing over the last several years. That then started placing pressure back into the data center power demands. And so what's happening there is that those chips, the microchips that are needed to assist with AI decisioning and AI training are becoming more power hungry. And so it was really that sort of uptick about 2 years ago that made us see that, okay, the opportunity has arrived. And that was probably a big part of the 10 years that expired, was finding the right timing. And as they say, timing's everything. And the moment for us arrived and the opportunity presented itself. And we decided that was the time to kick it off.
So you talk about moving the compute to the power, not power to the compute. Can you explain that in detail and why the industry hasn't built that way until now?
Yeah, great question. So to explain the electricity process, first of all, so you generate an electron and in a remote place, and 2 decades ago that was in a number of coal-fired generators in Australia. Over that period of time, there's been more renewable generators that have been built, so your wind and your solar assets. And so they're basically creating electrons out of thin air and then pushing it from that location, which might be hundreds of kilometres away from the cities, onto a high voltage cable. So the cables that you see going down the side of the freeway. And it travels, if you like, down those cables. I'll keep it simple. That doesn't quite move, but it has that effect.
It gets there.
It gets there. And so then it arrives at your location. It is then taken into your equipment. In your house, it might be your fridge, your television, whatever it might be. Turn your light on. In a data center, it's going into a server. And inside of that server, you've got your chips and the power is consumed and something of value is created. So there's a in AI terms, it'll generally be an AI token of some description is processed on that chip, and that process is complete end to end from a power perspective. Then what happens from a data center today and for the future will be that piece of data that's generated then travels out of the data center on some form of telecommunications network, fiber optic network is what carries that, and that's then sent to the user who's using the service, whether it's at your home or maybe across a mobile network into your hand. Basically, what we have done there is picked up the data center operations part, so the bit where the electron arrives into the computer and is then turned into fiber or into a piece of data that can travel on a fiber, and move that part of it to the generation. So in its simplest form, we've just cut out the part where the electron travels over a transmission network. And so instead of traveling across a big high voltage electrical system, hundreds of kilometers, traveling a couple of 100 meters from a panel or a turbine, and the processing happens on site. Now, the conversion of the electron into your processed piece of data still has to occur, and it does, and then it travels on fibre in the same way that it does for a metropolitan city. Now, the argument has been, or the positioning has been over the industry for many years, is that latency is a concern. So the amount of time it takes for the data to go from the computer to the user. And that is true for some applications. So some applications are more sensitive to that than others.
Such as?
Such as, say, a telephone call. So if you had a telephone call or a VoIP call that was had a high level of latency, the human brain can't detect latency until it's about 150 milliseconds of latency. That's when you start to notice lag if you've ever been on a phone call where it's a bit delayed.
There's a delay.
There's a delay, right, at 150 milliseconds. Computers see it a lot earlier, so they're a bit more sensitive. And so some applications have a concern for that. Other applications don't care. And more now, well-engineered services and applications that you use on the internet, whether it's in a web browser or on your email system, you don't notice it. You send an email to someone, you don't know whether that thing arrived in 100 milliseconds or 50 milliseconds.
That's true.
Right?
It's like, I've sent it. It's leaving my inbox. It's leaving my outbox.
That's it. As long as it doesn't sit in your Gmail 2-minute delay thing, right?
Yes.
And so some of those latency arguments are sort of falling away a little bit. The other thing has been that the telecommunications networks in Australia have ramped up in terms of their presence and where they actually are. And so over the last 20 years, again, there's been a number of foundational infrastructure pieces that have been built from the likes of Vocus, from the likes of NextGen, TPG, APT. All the carriers are building or have been building fibre networks. Telstra included have just rebuilt a lot of their intercapital network on the East Coast. And that means that the access to these fibre networks that carry the processed data is more plentiful. NBN's also helped with that to some degree as well. And so basically now the need to be in a metropolitan area sort of changes its requirement profile. And we can start to move these workloads that traditionally would have had to be in the city to be close to those telecommunications networks, start to push them out a little bit further from the city into the regional areas. And so that's where that kind of fits our model. There will continue to be a need for metropolitan-based data centres. You need something close to the users, particularly when it comes to AI inferencing or other latency-sensitive applications like your phone calls or your perhaps some form of interactive chat, for example. But more and more, the opportunity is there to be able to take the workload to where the electrons are being generated, and that is in regional Australia.
It's a genius idea when you think about it, and it just seems so obvious. Why do you think it hasn't been done prior to this?
Yeah, that's it's an interesting thought. It's usually the best ideas are the simplest ones. So it's not. You're right. It's not that revolutionary. But I think probably there's an element of it's the way we've always done it, so we continue to do it to some degree. In other degrees, you get a lot of advantages of being in the city too. You get a bigger workforce. You get easier access to infrastructure in terms of electrical systems, spare parts. All those sort of things are a little bit more readily available. But the thing that's not readily available is the key ingredient now for data centers, which is the power. And this is the constraint that we're seeing. And it's the same constraint that we saw kind of like this big 10 years ago, and it's now become this big, and it's going to continue to get bigger. we're seeing more and more from a transmission provider's perspective where they're having challenges trying to prioritize grid connectivity for not just data centers, all industries. New suburbs are popping up everywhere. New critical infrastructure like hospitals need to be built. All of these, pretty much everything in our lives now depends on electricity to some degree in some way. And then probably second after electricity is probably data centers. I've got a house of girls. Turn the electricity or the Wi-Fi off for 30 seconds and all hell breaks loose.
There's drama.
Yeah, that's it. So I think that's undeniable, but at the same time too, it's a question of how do we address that. The other thing that goes with that is the water concerns and other sort of resources, and so that's been quite topical. Data center industry has been pretty on top of this in terms of trying to reduce its footprint. We're fortunate that footprint in terms of water usage. We're fortunate that we don't necessarily have a lot of legacy to look after in terms of our infrastructure is newer. So we don't use any water. So we don't have a water hookup at WinDC. We are completely external water free, and we do that by using closed loop liquid cooling, much like the radiator in your car. But even the data centers that do have a need for water in their cooling systems have been pretty proactive in trying to reduce their water usage, and I guess we'll continue to do so.
So you've officially launched the business. It's called WinDC. You launched it in Sydney after everything that it took to get the business off the ground. What was that moment like for you?
It was a little bit surreal after talking about it and taking the actions that we had for so long, kind of just working diligently with the team and getting all the groundwork laid to have a room of, I think we had around 200 people there as we launched it. We had a fantastic night where we had some great entertainment. We had some great presentations and good panelists from the industry and abroad as well with our partners from Armada. It was surreal, but at the same time too, was very aware that that's the starting point. It's not the ending point. And so it's one of those things that, people sort of say, oh, it's just sort of popped up overnight. Well, it's, we're 10 years in, and I'm looking forward to seeing where we'll be in another 10 years from now.
Tell me, what has the industry reaction been to the business and its potential?
The reaction has been pretty encouraging. And so I think the industry acknowledges that there's opportunity for the country is huge. And when I say that, this is a global race for AI infrastructure. We're in the competition up against the Nordic countries are quite good at it because of their advantage in cooling systems. The US and North American markets are big because of their demand bases or their user bases. Other parts of Europe, Middle East. So we shouldn't kid ourselves that we're here to fight amongst each other from a industry perspective. It's very much an approach here where, as a country, we band together. There's different types of data centers that are needed, as I've already touched on, and the demand for compute exceeds what any individual operator can build. So I think there's been positive response. I think everyone knows where everyone's competitive advantage is. We're a relatively small up-and-comer in the market in terms of our capacities. But we have a big appetite to do things a little bit different. It's kind of always been in my DNA to do that. And I think the opportunity, if we get it right, will only sort of float all boats. It's the tide that floats all boats, effectively.
Am I right in saying that the plan is to use 100% renewable energy? How do you quantify that?
Yeah, it's that is the plan, and the reason why we've identified that as an opportunity is because power systems being under strain, we needed to find this way that we could basically create electricity from thin air, if you like, which is where electricity comes from, effectively, but truly from thin air. And so what we didn't want to necessarily be doing was, yes, we've taken the grid constraint off, but we also initially don't want to put more demand on constrained generators. And so, again, through our industry experience and our exposure to the energy markets, we identified that there's wasted electricity in the market. And so
how much?
When you put it all together, every year, Australia wastes about 2 million households worth of electricity. Incredible. And in data center terms, if you put all the data centers in Australia together, combined all their usage, and double it, that's what the figure would be. And so
just wasted,
basically can't be generated or can't be sent anywhere. And so that was really where our opportunity got even more refined, just to go there and say, right, you're a generator with electricity that can't be capitalised on, can't be sold. And so by having us at your location and by consuming the power on site, there's an opportunity too for the generators to improve their yield and make additional revenue out of an existing capital asset that they've already deployed.
So tell me about the actual data centres, because I've seen vision of them literally on the back of a truck. They look like a massive shipping container. They're portable, they're modular. How quickly can you get these centres from a location to the bush, get them fully functional? Tell us about that.
Yeah, so we very purposely work with our partner in Amada, which is a global design and manufacturer of modular data center components and edge computing platforms, and very intentionally made sure that our modules fit in the standard ISO shipping container footprint. So they're not a shipping container, but they look like a shipping container.
They look like one. Yeah.
So, and that's very, very particularly done because we want to make sure that we can use the existing logistics supply chains, whether it's by ship, by rail, by truck, and pick them up and move them around just like you would a shipping container. So from the time of order, including the manufacture process and the shipping process currently from Europe, there's a 90-day delivery and installation time, which is incredibly efficient when you consider that traditional data centers can take years by the time you get the approvals and the construction done and all those type of things. So we're talking like 3 months. And we're aiming to improve that in the near future with some onshoring of manufacturing. So we have a plan to open some onshore manufacturing as we get volume ramping up and be able to manufacture these units here in Australia and for our own use, but also potentially as an export back into our local neighbours in the Indo-Pacific region and up into Asia as well.
Have you been talking to government, by that, all sides of politics, and what has the reaction been to the business?
Yeah, it has been very positive from government at all levels, federal, state and local, which is encouraging. From our perspective, we're very much a bipartisan approach here. We have identified a challenge that the country is facing. It's not a challenge that necessarily has been created by any one side of politics or another. Some of these issues have been inherently growing for decades, and so quite simply, we're problem solvers in our organisation. And so we saw a problem, so we're trying to solve it, and that's the approach we're taking to this problem: is how do we get an outcome that is good for obviously the business, but good for the country as well. And so by not I guess adding to the challenge or adding to the existing constraints of water and power in metro areas, we're trying to avoid those areas and sort of pick up capacity and opportunity that didn't otherwise already exist.
Can you talk about cost and whether there's a cost savings that will be roughly the same? What does that end bill look like once your data centers are up and running?
Sure. I think we're very cost effective, and there's a couple of ways that we achieve that. Our modular design means that we can get to a revenue state much faster. So rather than deploying capital and waiting for, say, 3 years for a return, we can deploy capital and wait for a 3-month return. So that there's an advantage there, which we can ultimately pass on to customers. The big one would be the power. So from a power perspective, there's a big input cost into any data center. When you look at how a power bill is broken down in a metro area, there's a couple of components. So you've got...
I always close my eyes when I get my when I get my power bill.
It's like that. So if you were to break that down, it's generation, so the cost of actually creating the electron. You've got then the transmission cost, so that's the big high voltage stuff you see on side of the roads. You've got the distribution cost, so that would be like your Essential Energies, your Ausgrids, getting it down your street. Then you've got your retailer who's sending you your bill, and then some profit in there. So those kind of key things, right? If you think about our model, we take out the transmission and we take out the distribution costs. And so those costs are roughly about 40 to 50% of your bill. So that translates quite directly then into the cost of electricity that we can then use in data center facilities.
Would the end user in suburbia be able to utilise a saving on their power bill? Because that's a great headline, but I want to see if that's relevant.
Yeah, it's something we're testing. We are aware this is part of our social license, which all business operators and data centers need to be aware of, is how do we potentially assist in reducing power bills for consumers. I think it would be too early to say whether we do or we don't. But one of the things that we are thinking about is, because we're modular and because we're portable, we can not only go to a location and deploy, we can also retract from a location and was it dedeploy? Is that the right term? Undeploy? Yeah. Remove ourselves.
We'll look it up.
Remove ourselves from the site. And so if you think about a distributor of power like an Ausgrid or an Essential who's got to go build a new substation to service a new hospital and or suburb, whatever it might be there, they've got a capital cost that goes in there that they then have to recover from users in the area. Now, if we could go to that location and deploy our infrastructure on that site or adjacent to that site, as the suburb around it starts to get built, and then as capacity rises, we remove ourselves, then you get this effect of, well, the amortization cost of the capital is recovered earlier from day one at a higher utilisation, because we're there consuming the power, and there's a cost in the power that you pay for that. Again, there's more exploration, but ultimately that should help with consumer power bills on the distribution side. Talking about the transmission side, because our electrons that are used in WinDC data centers are avoiding travelling over transmission networks, it means you don't have to build the transmission networks. And you don't have to build the transmission networks. There's no cost in the transmission networks. And so there's an impact there as well. In terms of what it is, we'll wait and see how we can quantify that. But certainly we think as we continue to scale, that'll become evident about what that cost saving might be.
And if you have a look at a potential full rollout of your product, what does that mean for the potential for regional jobs?
Yeah. We plan to deploy in many locations, and we're planning to deploy many hundreds of megawatts worth of capacity. So we've got a good supply chain and logistics chain now, which is great. It helps us roll out at full tilt at the moment. We're looking to roll out up to 2 megawatts of capacity per week, and that can be in a whole lot of different regional locations and regional centres. That will obviously be determined by where electricity is being generated and initially where it's being wasted, and we'll target those locations to begin with. We've already got a number of sites that we're either under contract with or in discussions with to secure the power offtake. And in turn, we'll need workforce in and around those areas. But it's not just necessarily direct jobs at data centers per se. That generally also follows that there is some form of technology community that starts to arise around these type of facilities. And then, of course, we've also got plans to bring manufacturing onshore as well. So there'll be manufacturing jobs wherever that happens.
And since launch, Andrew, has your phone been ringing hot with interested parties from various parts of Australia wanting to know when they're getting their first data centre?
It's certainly been a busy couple of weeks. And thank you, Justin, for your help on that. We, since our news, I think, broke in the Financial Review 2 weeks ago, it's been exceptionally busy. Our launch event kicked that along again. And so I think, though, what I would say that everyone can see the opportunity more from a nation building exercise. And so where we're going with this is we really want to encourage the whole industry, but more so than the whole industry, the whole community and the Australian population to get behind the fact that Australia is really good at doing innovative, clever things. We've done it for a long time. We've invented all sorts of stuff. We invented Wi-Fi, black box flight recorders, cochlear ear implants, and those inventions have arisen for a number of reasons. Tyranny of distance is one where that's kind of originated, but we've got some real clever people here doing some real smart stuff. And so, as a country, if we can continue to punch above our weight and demonstrate to the world that we're a great place to be and a great place to trade with, that'll be good in so many different ways that far beyond what AI infrastructure alone can provide.
You're in market now raising capital. What can you tell us about that process and how's it going?
It's going very well. And again, the activity in the last couple of weeks since we've sort of come out a bit more publicly has been very encouraging. We are looking like we'll achieve our targets in the not too distant future. And so,
good to hear.
Which is great. It's very encouraging. We are sort of quietly confident because, as you know, anything can happen. There's a whole lot of variety of geopolitical things that are going on at the moment, and a whole lot of scenarios.
Indeed.
So, we think we've got the timing's pretty right, the market's pretty right. But again, this all comes down to execution, and so. Fortunately, we're not going first. There's been a lot of hard work by a lot of people over many years to grow the data center industry and into what it is today. So we're very fortunate to be able to leverage some of their efforts and education of the market around what a data center is, and that's helped from a capital raise perspective. So quietly confident we'll achieve those outcomes pretty soon.
You mentioned Armada. That's one commercial partnership. I imagine you're talking to lots of interested parties about business ventures.
Yeah, we are. It's a couple of different areas. So on the generation side, we've got site operators and asset owners that would like us to come to the sites to consume their electricity. A whole range of different parties there. On the offtake side, so who's going to use these facilities, a whole range of different cloud providers. So there's global ones, there's local ones, and then in terms of new partnerships, we've got some really interesting, innovative partnerships with a variety of different companies. Which
you're teasing us now.
Okay,
It's okay. You keep it under wraps if you have to.
No, I can let it out. But there's something that we've already announced. So we've got a great partnership with Megaport, for example, as our connectivity partner with how we're going to reach the sites. Yuriga is another one, which is a First Nations technology services company that specialise in cybersecurity for government defence. We've also got some interesting stuff happening in Western Australia with a partner, WaveX, there, and they are designing some industry-leading tech in wave power generation. Yep. SP Energy, in terms of a new project that we're working on with them for a new site, as well as obviously the offtake partners that I've mentioned before. So we've got great relationships with the likes of Sharon AI, with N-Scale and Nebius, we'd obviously like to talk to, and many, many more. And so, like I said, back to the the nation building concept here. They're obviously commercial outfits that we would like to effectively export Australia's energy resources to in the form of AI compute tokens. But then also we want to be able to contribute back to Australian research. It's an area that Australian researchers for some time haven't necessarily had the compute resources perhaps to keep up with their innovation. And so it'd be great to see some researchers come into the environment, as well as a variety of different non-NEAR cloud enterprises who are looking for green compute capabilities, which is what we can provide.
And a final question to you, Andrew. If you were to zoom out from where you are now and we looked ahead, what is your vision for WinDC? How many data centres have you got deployed, and where? Is it just Australia? Are you looking internationally? Paint us a picture of your best case scenario here.
Yeah, I think best case scenario would be to go where we're needed. We don't necessarily want to impose ourselves anywhere. We already have had demand in the last few weeks from overseas, people wanting us to bring our solutions there. We are focused right at this moment in Australia. But there's opportunity for hundreds, if not thousands, of these modular portable data centers to be deployed all over the place. And I think that's a real possibility, provided the demand is there for the services that we can provide, which, according to all reports out of, for example, GTC last week with NVIDIA, the demand just continues to grow. I think Jensen, who's the CEO of NVIDIA, on stage announced that they lifted their forecast on revenue for next year to $1 trillion. So I think that's almost double what it has been this year. So if that's any indication of where demand's going to head, then the opportunity is certainly very bright.
Andrew Sjoquist, founder and CEO of WinDC. It's been a pleasure having you on the podcast today. Good luck on the journey, and thank you.
Thanks again, Justin.